Hello, everyone. This is the recording for Algebra 1314, section 4.4. And we are going to do log equations. Well, exponentials too. Log equations. And what does equations mean? It means to solve for x. Yep. And you know what that means in this class? It means Desmos! Seriously, actually, yeah. Yeah, Desmos is super, super awesome in this section in particular. This is where it shines, and we will use it occasionally, okay? So I won't use it for every single one because it doesn't do everything for you. It'll do about 80-something percent. But there are some on the homework and even on the test that you cannot use Desmos alone. So I think it's best to practice with some of the easier ones so that when you have these other harder ones that you can't use Desmos on, you know what to do, okay? So, but we will use Desmos at least a little bit. Now, there's 4 methods, I guess, to solving some of this stuff. And so I'm going to call this one the cancel bases step. I don't know what you would call it. But basically, your bases are going to cancel, and you're left with something that's a lot easier. And I want to do that with 1 or 2 of these, and then I want to show you Desmos as well, like as we go along. So I want the same base on both sides. I got 2 on this side. I want to get a 2 over here. So that 16 has to be then 2 to the something, right? And this is where you get some Desmos scientific out. 2 power 1, 2 power 2, 2 power 3, 2 power 4. Cancel your bases, and then you're left with a much easier equation. Add 8 to both sides, divide by the 3, x equals 4. Okay. Now, I want to showcase Desmos, of course. I mean, as a good teacher, if I am a good teacher, I don't really know. But anyways, if I'm going to be a good teacher, I've got to show you how to do it by hand. But Desmos also, notice that the answer is a 4, right? Where's it colliding? Where's it x-intercept stuff? It's 4. Now, I can't click on it, but a lot of times what you can do is you can do a minus sign, and then it's clickable, okay? So let me just show you. So my original was an equals, right? And I can't click on it. Sometimes that's like inconvenient because it's like a fraction or something. So if you change your equals to a minus, a lot of times it's clickable now and you can get the answer immediately, okay? Now, I wouldn't just say that happens all the time. It really just depends on the problem. What you're doing here is you're setting it equal to 0. You're moving it over, setting it equal to 0. So that turns into a minus sign. As long as it's equal to 0, then Desmos makes it clickable, okay? So it works. Just be careful. You can't just say every time. You have to like literally move it over and then it would be fine, okay? But the quick method is just saying change it and you're done. So let's do some more. First off, I want to just say like, hey, some of these are going to be fractions. This looks like it's going to be a fraction, and maybe so. Let's get rid of that other one. So like, okay, see, what fraction is that? I have no clue. I don't know, Chad. So I'm going to change the equals to a minus, and bam. Now again, make sure you're clicking on the right spot. And there you go, right? There you go. So we got the answer. Is it just that easy? Yes, yes. But it is also easy to do the canceling bases method too. We know that this 16 is 2 to the 4. And 1/2 is 2 to the negative 1. Again, whenever you have a fraction, you're flipping it, make it negative. Powers of powers multiply, so it's technically a 4x. Cancel your bases, and so then you got 4x is equal to negative 1. Divide by the 4, so x equals negative 1/4, and there you go. There's your answer. Let's keep doing that. So this 125 is 5 to some power. I believe it's 5 cubed. 5 times 5 times 5. And it's always good to like verify this stuff. There you go. So cancel your bases, and then we're left with a much easier equation. Add the 6. 3x equals 9. Divide by the 3. And there we go. This one, you would think that the common base is a 9, but that's not the case. It's actually a 3. And the reason why is because this is not 9 to a power. So they both do have a 3 in common, though. Whenever you have powers of powers, they multiply. And here I'm actually going to also distribute, like at the same time. Cancel your 3's. 3x plus 9 is equal to 2x minus 1. Minus the 2x. Minus the 9. And so then I got x is equal to negative 10. Cool. What do they have in common here? It's not 4. It's actually a 2. And you could say that you're going down to the lowest number. That is perfectly fine to think that, like the lowest common number. But this is not 4 to a power. I don't think it's even worth me talking about it. Just go down to the lowest number, and that's generally going to be way better, okay? Distribute. That's a 6 now. That's a 6. Cancel your 2's. I'm going to minus 2x on both sides. I'm also going to minus a 6 on both sides. So then I got x is equal to a negative 12, technically. Here I think a 3 would be in order. That's 3 to the 4th, I believe. And then this is an odd one. Let me just triple check that. 3 to the 4th. 3 to the 4th. Okay, there you go. So this one's an odd one. Notice that because it's a fraction, it's going to have a negative. But it also has a square root, so it's going to be a half. So negative half. Negative square root. I'm sorry, 1 over the square root. So negative half. These are powers of powers multiply, so they'll end up being a 4x. Divide by the 4. Negative 1/8. Now, all of these could be solved in Desmos, even that last one. But again, watch out for your fractions, right? So here in particular, we got this. And again, I can't click on it. So if I change it to a minus sign, it's now clickable, generally. And there you go. See? Okay, so that was pretty cool. Let's do this one. So method 2 is ln both sides. Okay, so this is important. You will use this method a lot more than the other ones. Ln both sides. Look, take the natural log of both sides. There it is. So let me show you how this works, and we'll go from there. So solve for the variable. If you don't know what to do, like here's the thing. 4 and 15, do they have a 2 in common? No. Do they have a 4 in common? No. Do they have a 3 in common? No. Do they have a 5 in common? No. Got nothing in common. So you have to ln both sides. Now, I know that this is a weird thing to ln at this point. Like, man, you just made it a lot worse. But if you move the x down as a multiplier in the front, and then you divide by 4, or the ln 4 on both sides, that's just a number, ln of 4, then you would get your answer. There it is. Now, I know what you're thinking. Chad, that does not look right. Look at that silliness. Yeah, I know. But my math lab says it wants it like that. My math lab also says it wants this. It wants both. So, when you're doing your homework, you have to do ln of both sides. You have to. You can't get away from that. You cannot get away from that, okay? So be prepared to do what I'm doing right now. Also, then put it in and get a decimal, okay? You got to do both sides. You got to do that ln both sides stuff, okay? And the idea is that the power of the x power always will come down. That's why you're doing ln of both sides. So in a way, I'm kind of teaching you a method, and I can go into theory about it, but I don't think that this is the right class for like math theory. Raise your hand. Did you want to learn math theory? Then like, why are you taking this class? Didn't you want to take like our calculus classes and other stuff? So like math 1414 is our calculus-based algebra. It's the same class as this, but like twice as hard and twice as much work and all that stuff. That is the class that you should be in if you want math theory. Well, even not that, because we just got a lot of work to do in that class. You ain't got time for that. Anyways, there we go. So these are the two answers that they're going to want. They want the exact answer as the ln's, and then the x's are there. Same process, though. It's the same process as always. ln both sides, move the x down, divide. There you go. It's like 2 steps, maybe 3 steps. This one is a little bit odd because what we need to do is divide by the 7 first, so that's a nice and clean one. You could not do that and continue on, but it just gets nasty. So this one's way better. So I need to ln both sides. But you know what's funny about this? When you ln both sides, e and ln are going to cancel. The reason why is because we saw this last time. E and ln cancel because it's a log base e, and they cancel. So you're left with x is equal to this ln 34 over 7, and you're actually just done. That was it. So ln both sides is actually very advantageous, especially when you have an e already in the problem. Same thing for this one. Look, there's an e. So it's almost best to ln both sides because, boom, and you're done. That was the entire problem. Again, I have to stress that Desmos is not going to help you with this type of problem. You can't get exact answers out of Desmos here. For an example, let's just do that last one. I'll show you. So I got e power x is equal to 16.35. And for one, I just don't see anything. Oh, there it is. I can't click it, so I changed the equals to a minus. And yay, I got the decimal. I got part B. Yay! But what about this guy? Oh. You will have to find that stuff. Same thing with this. So those exact answers is required for you to do ln of both sides by hand, okay? That's why we're learning it together. And because this is a terminal math class, you'll never see it again. Yay! I'm very serious. Who in here is going to use this math right here? Looking at this math, who in here is going to use this math in their workplace? Come on. Nobody. Not even I would do it. I don't use this stuff much. I teach, but if you saw any of the other things I do in life, not just teaching, I still don't use logarithms very much. It's just one of those, useful for very select applications, which leads us into our next section. Anyways, minus 1 on both sides. E and ln cancel, minus 1 on both sides. Divide by the -4. And there we go. You might be asking, why are we doing all this then, if it's not going to be part of my job? You can ask somebody else. Ask your counselor that. Ask the state of Texas why algebra is a requirement for your degree program, because we didn't make that up here at CTC. It's that's a state of Texas thing. So there you go. Cool. So we did it, and we're done. Now, I do want to caution, this is the last question like this. I do want to caution one small thing, is that I'm not combining things together. Notice that even up here at the top, I'm not saying this is 15 divided by 4. And let's just compare and contrast for a second here. Let's go back to this problem right here. Okay, and what if I did 15 over 4? They're not the same question, or not the same numbers, right? I can't just cancel LNs. Cancel LN. No. Because LN stands for log natural, but it also stands for locked in. Yeah, locked in. And so whatever number you have inside the LN is locked in. 15 is locked in. 4 is locked in. You divide them. 533 is locked in. But look, I want a minus 1 to it. No, because this number is locked in. Hey, can I just divide by 4 right quick? It won't be too bad. No, because it's locked in. That's why you have to keep it as you see it. It's locked in. There's nothing else to do. Okay? Good talk. Okay, next method. Oh, they say method 1? It's my method 3, bro. So, just rewriting the book. This one here is, I would call it like the friends methods. We're trying to just solve for logs. It's kind of like going backwards a little bit. But friends is what I would be using for most of this stuff. And the friends method I already showed you back in section 2, I think. So here we go. I see my base is a 4 up top and on the side. So I'm saying, 4 and x plus 3 were good friends. No longer x plus 3 yourself out of here. Yeah. Find an exit. And then 2 is all by himself. And oh, look, now we're a pair. Oh, did you catch that? A pair? See, we're a duo. Oh, because it's 2. 2 means like twice. We do it twice. Okay, it's a pair. Okay. Anyways, 4 squared is 16, and then x plus 3 minus 3 on both sides, and we're done. Could I have done that in Desmos? Well, yeah, because this is an integer answer. Duh. That's fine. Could you have used Desmos in all the last problems? No. And that's why we're still doing it by hand, so that we're prepared for anything. Look, there's 13. Oh, I can't click it. Change it to a minus. So, cool. This one here, I'm going to divide by 4 to start with to make it a tiny bit easier. If you do like a power rule, it actually gets really messy. So this is way better. Divide by the 4. And then to get rid of an ln, you can e both sides. Kind of like when you ln both sides. Now I'm going to e both sides. You can also do the friends. It's going to be the same thing. And I got 5x is equal to e to the 4th. Divide by the 5. And there's your answer. E to the 4 over 5. Desmos will not give that to you, so you do have to do it by hand. That's okay. I got an ln. What cancels with ln is e. So if I e both sides, or again, you could do the friends. It'll be the same result. They cancel. And I need to get rid of that square root. So what I'm going to do is square both sides. Those cancel. And so I got e squared. That's kind of weird, but, well, there you go. Minus 1 on both sides. Whoop. And there's your final answer. So e to the 2 minus 1. That is what they want in my math lab. Okay, this one is a lot longer. So I want to show you something, okay? You got that math ASMR going on? Scroll out, 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 and I see one answer. It looks like a 6. Your answer's 6, okay? I'm serious, man. You see this on the exam, heck, on a quiz? Please, just do what you got to do to get it right, you know? On your homework, you should be practicing. You should be learning, because these skills come up in other problems. But if you see something crazy, please, just do it with Desmos, man. Get it right. So, let's try to figure this thing out together. First off, there's a plus sign, which means that we can combine the insides together with a multiply, like that. Okay. I can do my friends. So base 5 up top on the side. Just kind of made it up really fast like. 5 to the 5th is a bunch. Okay. And then I'm going to FOIL this one out. Oof. Oh man, what's 119 times 19? Eek. And then I'm going to subtract this to the other side. That's a 2. And then I'm going to combine these together. Oh man, look how much math this is. Skip to the end. That's a 4. Okay, and then I need to factor this. Ugh. What two numbers multiply to 864 but add up to 138? It's fine. I'll wait. Is there a 2 in there? There is, but those things ain't going to make a 138. What about a 3? Still, again, I'm adding these two numbers to get a 138, and that's not going to happen. A 4, 5, a 6, a 6, a 6, a 6, because 144 minus 6 is 138. There it is. Whew. So when you solve for x, I got a negative 144, and then I got a positive 6. There's my answer. Wait. 6. Look, hold on. This scale is all wrong. I'm supposed to go check on negative 144. I didn't scroll out. Go back. Go back and look. I did scroll out. I did scroll out, and it's not there. It's not there. It's not there. It's not an answer. Okay. I'm going to write down double check. Because what's happening is that when you have especially two answers, you should double check. When you got a pair, you should do this a couple of times. Because you do it twice. You double check it. Oh, that's a funny word thing again. Okay. So when you got two answers, double check it. And if I typed in right here, if I put in a negative 144 right there, what I would get is a log of a negative number. And the whole thing blows up. That's why that one doesn't work. But yet, if I put a 6 in there, it's fine. If I put a 6 in there, it's fine. So my bigger point that I'm trying to make is that Desmos got it done a long time ago. And he didn't have to double check it, did it for you. Whew. All right. Well, I showed you. As a good teacher, I did it, huh? Yeah. Okay. Method 4. There you go. Method 4. This is when you're canceling your logs. So if you have the same log on both sides, you can just cancel logs out, and then you have something easy. That's what we're going to do for these guys. So notice there's a minus sign between those. So what that means is that there's going to be division. And then you cancel logs. And it is easier. First, it's best if I multiply by the 2. So then I get a 6x plus 4. I'm going to minus an x on both sides. And I'm going to minus a 4 on both sides. And so what I have now is a 5x is equal to negative 1. Divide by the 5. And yeah, Desmos would have done it, but but I need to show you by hand just cause. Just cause. Like, just cause. Okay. So I have to laugh at myself because no one's laughing with me. Maybe I should get some canned laughter, you know what I mean? Little recording going like, ha, 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 ha. That would get so annoying. So no, I'll just continue doing what I do. Log. Oh, so there's a plus sign, so it's a multiply on both sides. Cancel your logs. I'm going to distribute this log, so I got an x. Distribute your x. So x squared minus 7x is equal to 18. Move this guy over. Okay, and I want to factor that. What two numbers multiply to 18 but add up to 7? I think it's going to be a 9 and a 2. But notice it's a negative 9 and a positive 2 to make the negative 7. So x equals 9, x equals negative 2. Whoa. I got two answers. You better darn well double check. And so whenever you plug in a 9, it's fine. See, you plug a 9 in right there, it's fine, because 9 minus 7 is 2. But if you plug a negative 2 in, log a negative 2, just right there, doesn't work. So x is equal to 9, only 9. And again, Desmos would reflect that. Let me just demonstrate, because that's what I do around here. Oh, I wonder what that number is. Was there anything at negative 2? Nope. Last one. Oh, man, I'm bored. So, is it the last one? No, it's not. It's the last one without the it's the last one without having to do other stuff here. Applications. Okay. Aha. Aha. Ooh. I know. I'm going to change this equals to a minus like Chad said every time. Whoop, whoop. Where'd it go? Whoop, whoop. I fooled you, didn't I? Well, what's going on? What's going on is that because there's two things on that side, replacing that one minus is not a good thing. You'd have to change both signs. This would be a minus, and this ends up being a plus. And then it's set equal to 0, because like you have to move it to the other side kind of thing. So just as a demo. See, came back. Came back. So then 6.333. 33333333333333333. Rude. So 19 over 3. There's your answer. Yay. Let's prove it, though. Let's prove it, okay? So let's do this. That's an equals. This is a minus. Here we go. So log minus a log. You have division. Log minus a log. You have division. Logs cancel. Can you see why I had to use Desmos on this one? Look at this. What are we doing? Ew. Multiply, like move it up to the other side kind of thing. So x plus 15, x minus the 2, x minus the 1, x plus the 11. Then I have to FOIL, or moon thing, or whatever that is. Looks kind of like a moon. X squared. Let's just cut to the chase. It's a positive 13 and a negative 30. And this is x squared. That's going to be a plus 10 and a minus 11. Cancel your x squares out, because if you minus x squared on both sides, they cancel. I'm going to minus the 10x. I'm going to add the 30. Oh my gosh, Chad, this is nuts. Is that a 19? That looks like a 19. Divide by 3, and oh wow, we finally got the final answer. Now notice I only got one answer. If you get one answer, you generally don't have to double check it. It's only with the two answers, but that was just a little hint. I would say you always have to double check. Yeah, whatever. So there you go. We did it by hand. Yes, but you just skipped ahead, didn't you? So on the video. Okay, so there's two application questions, and then we're done. The next section is all applications, but that means a lot more Desmos, because Desmos gives us decimals really nicely. This is a good thing going forward. I'll show you how Desmos will help us even more. But for right now, let's just finish this up. It says t is years after 2000. What's going on in 2000? So like t equals 0, because no change at all. I'm going to plug that in, and we're going to get an answer. So 18.5 e to the 0.1718 times 0. And 0 times anything is 0. I'm making this like way drawn out. Anything to the 0 power is a 1. And so your answer was this the whole time. Okay, cool. But then it says, this is my answer, go and find the t. As in like 26.6 is equal to the 18.5 e to the 1718 t, solve for t. So what we do is we divide, and then we're going to get a number. Clear all. There you go. Okay, so 26.6 divided by 18.5. So now I got a 1.437837. I would say go out a couple places just in case, because I don't want you to round and then it's wrong or something. So I divide. And then the next thing is I'm going to ln both sides. So ln of the 1.437837 is equal to ln of the e, t, and e and ln cancel. Oof. So what is that ln of that thing? So ln of answer, ooh, look how fast I can do that. You just literally type ANS, and it just pops up in Desmos. So that's pretty cool. 36314. Again, try not to round very much. Is equal to a 1718t. I'm going to divide by the 1718. So I'm going to divide. And what you saw is our method called divide ln divide. Divide ln divide. And you get the right answer like every time. We'll be using that method a lot. So this is years. We'll be using that method a lot in the next section, divide ln divide. But also, there's quicker ways to do this. Desmos also will help you. So that's cool. All right. It's wrong. What? What? Well, kinda. It's this, but it says when will it reach that? And they're looking for blah, blah, blah AD. And what we have to do is add 2,000 to it because that's where we're starting is 2,000. So 2,000 plus 2 is 2002. And I don't know, maybe February? January? 2002. Yay! Now we're fine. Okay. Last one. I'm going to plug all these numbers into my my formula and just get an answer, kind of. Well, actually not. I have to solve for t. So let's plug it all in as best we got. So 25,000 is equal to the 11,500. 1 plus my rate is 675. Notice my decimal form. Compounding periods is 4, and then 4 times t, because I don't know how much t there is. And I need to solve for t. I want to use Desmos. Like, just between you and me, I did this by hand on my workbook, but it's just totally not worth it. I'm sorry. It takes forever, and then you're left wondering, why did I do all that when Chad's just showing me Desmos, right? Okay, so I type it all in, and it goes, Do you see what it says? What do I do? I'm waiting for you. I need to change it to an X. So now it works. You can see it's working. But I don't see the answer. Because it's, again, in years. I don't know how many years it's going to take. So scroll out. Oh, there it is. You scroll out, and there it is. I can't click on it. So generally, I change the equals to a minus. See, it's clickable now. And so there it is. We're done. We're done. That was it. That was so easy. And it should be. This is the easier algebra class. Please, don't make this complicated, man. Let me just verify that I did this all by hand on my workbook here. I did. That was so sad. It took forever, man. I would recommend not. I would recommend this. Did I get the same answer? Sure did. Desmos, man. Desmos. Okay, cool. We're done with that section at least. Thank you very much. Have a great day.